In section 2B, we're now looking at notation for functions. Many of you may have seen this last year in Year 10, but let's do a quick review of it. We've got this f of x notation, which means we've got a function and our variable is x. Sometimes you'll see it written in this form, where we're saying we have a function, the variable is x, such that, and that's what that symbol means, such that the x becomes 2x squared plus 3x plus 1. So whatever is written here, not this way, is our input, and whatever is written over on this side is our output. So that's obviously, again, corresponding to our domain, has to do with the x's, and our range has to do with the y's. Our range, our domain. You probably have seen a lot where it was written as y equals 2x squared plus 3x plus 1. And we often use this sort of notation when we're describing a graph with x and y axes. So when we write y equals to f of x, it means we're graphing the function in x. So this is our f of x notation. F of x is equal to 2x squared plus 3x plus 1. So we're saying it's a function, not just a relation, and this is the rule for working it out. You'll also see other types where we've got, in this second example here, s of t equals 3t plus 1. So again, it's a function, even though we're not using the f letter, but the variable in this case is t. So our equation is going to have t values in it, as opposed to x. If I want to say what is the value of the function at 2, so going back to our original function here, f of x, then that's just saying wherever there's an x, substitute 2. So that would be the same as 2 times 2 squared plus 3 times 2 plus 1. And calculating that out, we've got 8 plus 6 plus 1 is 15. So that's saying the value of the function when x is 2 is 15. This one here is saying what is the value of the function when x equals t, whatever t might be. So t is our parameter. And so you just substitute it in. So the equation becomes 2t squared plus 3t plus 1. So whatever's in this position is what you're substituting into your equation. So let's look at some other examples of these. What I'd encourage you to do is have a look at them and stop the video, have a go at filling them in, and then turn it back on to see the answers. So in the first case, what you're doing is you're substituting x with minus a. So wherever there's an x, substitute in minus a. In the second one, you're substituting t plus 1. So wherever there's an x, you're putting in t plus 1. This one says, wherever there's an x, substitute it with a, but then take the opposite of the whole function. There's one more down here if you'd have a go at, 2 more. This next one here, it says get x in the function f of x, now multiply all by minus 5. And this last one is saying, wherever there's an x, now substitute it for x plus h. This is going to be common when we get to start to do calc, and you'll be doing a lot of calculations with this. So at this point, stop the video and have a go with each of them. Okay, how did you go with that? Each time you do this, make sure you show your substitution. It's always important in your first line of any work just to show straight substitution and then simplify it. So don't forget minus a all squared becomes the positive, Expand your bracket for there. In the next one here, we've got the t plus 1, expand that all out, make sure you do that correctly and expand this bracket as well. Combine like terms to get your 7t. In the next one, you're just taking the opposite after you've substituted in the a, so there's the minus, use your brackets. So substitute the a, then take the opposite of everything. In this next example here, we're doing minus 5 times the whole function, so just expanding that to get this result, minus 10x squared minus 15x minus 5. The last one looks pretty complicated, it's just a bit tedious. So you want x plus h all squared plus 3 times x plus h, so expand it here in this line. That's already expanded, and at the end, you can't combine any more like terms. They're all different terms. In this case, our variable is x. It's still the variable of the function. This other letter here, does anyone know the name of that one? We call that a parameter. So a parameter is any other letter that we're using to represent some numbers that affect the equation. So hopefully you had a good go over those and got most of them correct, or all of them correct. What we want to now do is look at some calculations involving this f of x notation. So we're taking the same f of x function, but now we're asked to solve f of x equal to 2x plus 3. So in an IB question, it would be something like, given f of x equals this, then solve f of x equal to 2x plus 3. So what they're saying here is that 2x squared plus 3x plus 1 equals 2x plus 3. What we want to do is go through and solve that without a calculator. So just back to your normal solving for a quadratic, you're just going to bring everything over to the one side. So we get 2x squared plus x minus 2 equals 0. Then if you want to solve this without a calculator, what are your methods for solving? You've got several strategies. If you think about those first, you can stop the video while you look back and refer to them. Your two strategies could be, your first one, using quadratic formula. Your second strategy would be solving by completing the square. You need to be able to do both. So how about pause the video and have a go at doing those, then while I do the answers, then you can have a look again. Okay, so quadratic formula, you should be able to do that by now. So just substituting in, what's your minus b for minus 1? I always show this substitution in your quadratic formula as brackets, so you make sure you get that all correct. Simplify it and you come down to that answer. If you're doing it with completing the square, take your constant over the other side, remember, divide by your 2 to get that leading coefficient of 1. So that's a half here. You need to add a quarter squared to both sides. You should be good with working with fractions. So we get 1 plus 1/16. Put that together as an improper fraction here. Then you can now take the square root of the 16 to get the 4. And you come out with the same answer. So you should be able to solve both of those. Either way to get the, remember this is called our exact solution. So this is like a paper 1 question, no calculator, and you come out with your exact solutions. Let's now have a look at using your calculator. How would you do this with your calculator? So we're going to look at this in class and run through this, showing you how to do this with your polynomial tools and then by graphing. and then we'll look at this last example. So let's leave it there, and then we will do this in class. Don't forget to have your calculators with you.